Welcome to this lab on understanding images with Google Cloud. In this lab, you'll experiment with pre-built models so there's no coding. First, you start with the Vision API, which allows you to obtain predictions from images without having to train a model. Then you use AutoML Vision, which allows you to train a custom model and deploy it using only your labeled data. Let's start with the Vision API. The Vision API is an API that uses machine learning and other Google services to extract information from images. It can do a variety of things, whether it's detecting the presence of certain classes within the image, detecting and extracting text, determining if the image is safe to serve, or detecting the presence of corporate logos. It's easy for developers to write simple lines of code that use the API to make predictions, but in this lab we're going to focus on doing things codelessly. In a separate window, navigate to cloud.google.com/vision, and you should see a web page like this. Once you're there, scroll down to the box labeled Try the API. To use this feature, you'll need to upload an image from your computer. We've supplied a link in the instructions for which image to use. I'm going to drag the image onto the web page, and then we can get some predictions. The web page will display the results of a number of different API calls, including label detection, web detection, which looks for entities in the image, and safe search. The first tab in the label holds the results of label detection, and note the top classes. This image was of a cirrus cloud, but is cirrus cloud among them? No, it's not, and it shouldn't be. This is because even though the Vision API knows about a large number of classes, it doesn't distinguish between every sort of object in the world. In real-world implementations, calls to the API would be made programmatically, but you should now understand what each one of these calls can accomplish, and that the Vision API is powerful, but limited to the set of high-level classes that it was trained with. Unlike the Vision API, AutoML Vision can be trained to use whatever classes you need for your business use case. To check out AutoML Vision, first click on the navigation menu, scroll down until you see Vision within Artificial Intelligence. This will open up a new window. If you're prompted, make sure to select the account that you've currently created. In my case, I've already done that. You may be prompted to set up the necessary APIs and service accounts. Follow the instructions in the reading materials to get through that. Once you have, you should see a screen that looks like this. Click on the New Dataset button. Enter in clouds for our dataset name. And then check the Select a CSV from on cloud storage and add data.csv to the end of this path. Once you're done, you can hit Create Dataset. It may take a few minutes to process the images, but once it does, it should look like this. Note how we have 60 images in our dataset, and all of them have been labeled. The labels that we have are cirrus, cumulonimbus, and cumulus, and there are 20 images in each. If you click on a label, you'll see the images that have that label. And then you can select an individual image. This is useful if some of the labels that you have are mistaken. If I clicked cumulonimbus here, it would change this image from a cirrus image to a cumulonimbus image. And I could then click the OK button, but I'm not going to do that. In the Human Image Labeling Services demo, we saw how when other humans label our images, we also have the opportunity to approve or reject their labels in a screen that looks like this. Once you've reviewed all the set of labeled images, you can then click on the Train tab to train your own custom model. In this case, the UI is prompting you that you really should have more images per class, and you should. But in this case, the number that we have suffices for our demonstration. So I'm going to click Start Training. When you train a new model with AutoML, you're automatically given 1 compute hour for free. And you can also invest additional compute hours on top of that. Training can sometimes take a long time, so I'm going to pause this and pick up when the model is finished training. On my computer, this took about 5 minutes. Once your model is finished training, you can click on the Train tab to see the results. In this case, we're shown two metrics, precision and recall. And recall that precision takes the ratio of the true positives to the set of all positives returned, and recall looks at the set of true positives that were recognized compared with the set of all positives. So this is a measure of how precise things are, and this is a measure of how exhaustive your model is. And these two are fundamentally in tension. A model that could be completely exhaustive might lose all its precision because it says yes to everything. If you click on See Full Evaluation, you can break down the results a little bit more granularly. Notice that we have a score threshold, just like in the other labs that we've done in this course. The score threshold is what the model uses to actually make its decision. We can see how precision and recall are in tension by manipulating the score threshold. If we set the score threshold very high, then our precision goes to 1, but our recall drops very low. And the reason our recall drops very low is that very few of our candidate images actually are rated with a perfect 1.0 threshold. In contrast, if we lower our threshold to 0, suddenly our recall gets much higher, but our precision goes down. We can also break down our results further with a confusion matrix. This tells us the extent to which the model is confused, the extent to which it thinks an image is one thing when it's in fact another. And what you want to see is a model that has most of its decision-making mass along the diagonal. That is, it recognizes images for what they are. In this case, it's able to recognize all the cirrus and all the cumulus images, but struggles a little bit on the cumulonimbus because it thinks some of them are cumulus. It's oftentimes helpful during iterative model development to look to see what it is the model did well on and what it is the model didn't do well on. Oftentimes that can inspire new decisions. If you click on Labels in the Labels panel, you can see individual images that are true positives or false negatives. So the true positives are ones that the model correctly identified as being members of that class. In this case, this true positive had a score of 0.854. So if the score threshold had been higher than 0.855, this image would not have been considered to be a cirrus. We can also look at the false positives, images that were considered cirrus but aren't in fact. This is an example of a cumulus. We can also do the same thing for other classes. In this case, this was in fact a cirrus cloud. ML model development is often iterative, and it can be incredibly useful to examine performance within each class in order to understand what to change in the next iteration. Select the cirrus class, and you'll see both the true positives and any false positives or false negatives. In this case, all of the cirrus were classified correctly. However, for cumulonimbus, some of the images were classified as true positives and others were classified falsely as negatives. So these are examples of actual cumulonimbus clouds that were classified as something else. If you click on them, you can see why. The correct value is cumulonimbus, and its confidence or score threshold or score value is only 0.123. The model, however, thought it was cumulus and gave it 0.83 for that cloud type. So the question is, what does this represent about the phenomenon being modeled? And how can we use this to inform our iteration? Do we need, for instance, to find more images like this so that the model recognizes that this is a general phenomenon? Now it's time for the most important part, generating predictions on your trained model using data it hasn't seen before. To make predictions, navigate to the Predict tab in the AutoML UI. There are a few ways to generate predictions. In this lab, you'll use the UI to upload images. You'll see how your model does classifying these two images. The first is the cirrus cloud. The second is a cumulonimbus. First, download the images by right-clicking on them, which I've already done, and then click on the Upload Images button. And when it finishes, it should look like the following. For the first one, it says cumulonimbus, and the score is 0.997, which indicates high confidence. The second one, it predicted cirrus with a confidence of 1.0. And that's it. You've trained your first custom model. And note how, in this case, we were able to define the classes ourselves just from the data that we had, unlike in the Vision API, where we were forced to use the classes that the API already knew about.